Hello, thank you for joining us and taking the time to attend this webinar today. Accelerate decision making with faster analysis and data search. My name's John Aldred, and in the next 45 minutes, we're gonna be looking at some of the newer features in Aqira to help engineers find data and also more quickly process large amounts of measured data. And we've got quite a bit to cover, so let's get started. First of all, by introduction, Prenscia, we help engineers deliver durable and reliable products and avoid the cost of unexpected failures. That's what we're about, and we do that through two main established software brands, nCoDE for durability and durability engineering and covering the physics of failure, and ReliaSoft for reliability engineering and the statistics of failure. And then we also provide training and education, either on-site or public courses, and also services, so either for materials testing and also consulting services. And in terms of the software product range, on the left-hand side, we see that contains the tools for reliability analysis under ReliaSoft, for failure data analysis, test planning, system modeling. The remaining ReliaSoft products there are related to reliability management, things like FMEA. And then we also have our nCoDE tools for durability and durability analysis of measured signals, and also vibration analysis. And what we're focusing on today is the Aqira product. So let's look at that in more detail. So let's define Aqira. Aqira helps engineering teams with increasing workloads of analysis to be more effective and efficient through easily configured web apps. That summarizes what Aqira is about, and we're gonna demonstrate that today, and hopefully you'll see some of the ways in which we make that a reality. So in this webinar today, we're going to cover three main topics. We're going to look at remote nCoDE, which enables work from anywhere, and in the current situation enables work from home. So that's an aspect of Aqira that we're going to cover today. Secondly, we're going to look at data search, how to find data, and specifically we're going to look at finding data, for example, on shared drives. That's a common way in which data is stored within engineering organizations, and we're going to take that as an example. And lastly, we're going to look at EncodeDS, which is a brand new signal processing platform that's available within Aqira, and we'll show how that helps you accomplish 10 to even 100 times faster signal processing. So those are the three main topics we're going to cover in this webinar. So to give a little more background on what Aqira is, for those of you who are familiar with the existing nCoDE product range, we have desktop tools, for example, DesignLife, GlyphWorks, VibeSys. They take measurement data from the lab or from testing, and also simulation results, especially in the case of DesignLife, combine those together and enable you to, in a very interactive way, perform durability calculations and data analysis. Aqira helps you take that to another level. It's a server-based platform, and then, as you'll see today, it gives you web-based access to those exact same desktop tools that you're used to running on your desktop, now able to access that via the web. It also provides several other capabilities. Data search we'll be looking at today. There's also the concept of the ability to create apps. In other words, be able to create streamlined, simplified processes to democratize analysis, to be able to share that with more engineers. And has functionality around license tokens. And another topic we'll be talking about today is nCodeDS, which is a brand new engineering analysis platform which uses a streamed analytics approach for analyzing data, and through that achieves a great increase in terms of an analytic performance. And additionally, another reason for Aqira is the fact that we see the landscape of data changing as we go in, as more and more products and equipment are connected, increased volumes of data, increased streaming of data, and Aqira really is that platform which we can base not only the existing types of analysis that people do with test and measurement type data, but also more connected vehicle and connected equipment type data can be streamed in. So that's all part of the roadmap of where Aqira is at and where it's going. So the first topic that we said we talk about here is remote nCoDE. So what's this? Well, remote encode is a version of the encode products that you're familiar with, the desktop type products that are now hosted on a server as part of Aqira and enable you then to run those interactively in a web browser. Aqira has the ability to store the kind of analysis flow processes that we use within GlyphWorks and Design Life, and those then flows can be open within remote encode and run directly through the browser without having to have a local installation of encode on your local machine. And also you can create brand new processes from scratch, as we'll see in a bit. One benefit of this is it means that all your users within an organization, rather than having their own separate installs of encode at different version levels, different patch levels, have all got access to exactly the same version. That can certainly simplify processes. So Aqira is installed on a server, it's installed on site, it's installed on company server, and that the Aqira server would then have access to whatever data is in your own network environment. And that's, as we said, typically within a company network. Now, in the current situation, people working from home, for example, you and your colleagues now have to be able to access data that's in your company network, requires some kind of VPN access in order to access your data or even your own computers or servers, and Aqira would be exactly the same. So from work from home with Aqira, you would still need to have a VPN connection into your company network. So one question is how is this then better than, for example, using a remote desktop? Well, some IT departments just don't like remote desktop for security reasons. So that can just be something which is a concern, full stop, to be able to have to access a machine directly from outside of the firewall of your own company. Remote desktop also then requires whatever computer you're accessing, if it's your own actual desktop machine or your laptop, it has to be constantly on, constantly available. And that can actually become an IT challenge, especially with things like Windows updates or power issues, requires someone to go in and actually do something to the machine. That actually seems to happen quite often. So remote desktop, although it works in the short term, for a long-term period is problematic from a maintenance perspective. The alternative, of course, to having to access a central machine is that you just have nCode installed locally on your laptop, and we've certainly been helping customers with that. And that's great. And that's totally a great option to have nCode installed locally, have GlyphWorks running on, for example, on your local laptop. But that has the opposite problem, whereby if you're analyzing data, now all the data you need to analyze needs to be on your local machine to analyze it, and vice versa in terms of results. So there's a lot of data transfer, a lot of time-consuming data transfers from company shared drives, for example, in order to perform that sort of local processing. So that's going to be a downside. On the other hand, of course, by running Aqira, you're running it over the web, you've got a central, accessible installation of encode that can access the data that's on the servers. That can save time in that scenario of having to download it. But it also provides, Aqira provides built-in collaboration tools to help with the analysis, for example, for sharing the analysis flow, standardized processes within the team. So going beyond just the ability that you can run encode through a web browser, Aqira also provides those standardization techniques, because otherwise what you end up with is you have different islands of analysis happening on different people's machines, separate files on different PCs. You've got problems of, in general, different people using different copies of the same analysis process, each running on their own separate machine. There's no version control. No one knows who's doing what. There's very little documentation, and this is quite common in a lot of our customers. Is there's a lack of control in terms of the analysis processes, and companies do their best to try and do this manually. But what Aqira provides is a way of standardizing analysis such that not only can you run encode over the web, which we'll look at in a second, but it also enables you then to standardize and share processes between version control processes between users. So Aqira has a concept of a flow list, which enables process management. So it enables you to manage processes in a central location with version control. You can also store additional information and documentation with each of those processes. So let's jump out of PowerPoint mode and actually look at some live software. So I'm going to do some live software with Aqira here. I'm going to jump into Aqira. So hopefully you can see my screen there. Otherwise, hopefully you're going to shout out and let me know if you can't. So this is an instance of Aqira. You can probably see I'm running a Chrome browser. I've logged in already. And this is a Chrome browser. And so I've logged into the Aqira system. And this is a dashboard you see when you log in. You can configure it to show whatever you want. Here I'm also showing some results from a design life analysis, and built into Aqira is 3D viewing capability over the web for FE models. Right now it's focused on design life results, but you know, we're going to be extending that capability as we move forward. Over on the left hand side here we have the main menu for Aqira, and we have what's called a flow list. And this is a list of flows that people have put into the system here and shared information. For example, this one doing relative damage spectra calculation. Let's say I want to, as an engineer, I want to find a standardized report. I can search on the flows that are in the system. And here's a GlyphWorks flow that's already been put in the system. I have to click this button over here for open. What you'll find is it will then create a new browser tab, and it's going to open that GlyphWorks flow. It's going to open GlyphWorks, but that's all now running fully server-side and fully interactively. So I can now interact with this flow, even though it's running on the server. I can change the properties to change the analysis if I wish, or I've got the proper permissions to do so. And in this example, let's just see what data file. I've got my working directory here. Again, I'm working on the server, so this is data that's available to me on the server. I'm going to select this Encode S3T file, which is, as you're probably very familiar, it's a time series data. Again, it's fully interactive. I can work with this data and press run, runs the process and creates a PDF report. That is the purpose of this flow. So from that, you can see that without just having a web browser, nothing installed necessarily on my laptop, this is all running. Actually, this actual instance is running in Azure. This is a cloud install of Aqira I'm running. I've been able to run this process. If I go back into my main Aqira window, go to what we call remote files. This shows me my working area. You'll find here's a PDF file. There should be that's just been created. There we go. 1014. I click on this PDF. I can open that up. Hopefully you can see that as well. So that's the PDF I've just created, which is a PDF of all those channels that I just analyzed, create a PDF, all fully server side, but I can obviously download that as I need it. So that is what we mean by remote encode. If I exit this now, if I exit out of this, ask if I want to make changes, save the changes, I'm going to say no. Instead, I'm going to go back to the flow list. And so what I did there was open an existing flow. I just want to demonstrate that I can also say new flow. And it's going to start from a clean sheet of paper, just like you're used to with GlyphWorks or Design Life. And I can then create my own process from scratch. And press play. And there you go. Very, very simple analysis process created interactively, which I can then save back to Aqira and share with other users. I can put permissions on that in terms of who can access it, and I've now got a version controlled and permissions controlled analysis process in Aqira for other users. So hopefully that gives you some idea of what we mean by remote encode. It helps you to have a standardized analysis process, not only accessible through the web, but also with standardized version controlled processes. Let's jump back into the PowerPoint for a second. So that's what we just looked at. One thing that's worth pointing out is that, as you're probably aware, if you create Encode flow processes, they can get quite complicated. And apps are a way to create an easy to use front end for what could be a very sophisticated analysis process. So the idea is you take what is an analysis like you see on the screen, lots of different glyphs, lots of different steps in the analysis process. And what we want from an app in Aqira is we want engineers to be able to create easy to use processes that other engineers can use without having to understand all the details of what's going on. So what we want to be able to do is we want the engineer to be able to provide a front end that users can then answer a few simple questions that are relevant to the analysis, pick some files, hide all the options that aren't relevant, just expose the questions that you do want the users to use, and then show the results in some kind of obvious or intuitive way. In this case, the results from an FE model, from a design life analysis, but it could be any sort of result of analysis that's been put into that app. So what we want to be able to do is embed into apps analysis processes like running GlyphWorks, like running Design Life, but we can also put into apps user configured analysis. For example, there's a Python scripting capability, so you can really enable a lot of high level of customization. And so apps have the ability then, we have other webinars that we've recorded with more details on how you create an app, so I'm not going to go into that today. There are other webinars on app creation, but the basic principle is that if you're an engineer capable enough to create a GlyphWorks or Design Life process, then you should be able to create an app, drag and drop, without having to do any scripting if you don't want to. So that's apps, and that's also by way of introduction to the next topic, because we're going to use apps in our next topic, which is related to data search. So I don't know if this sounds familiar to you, but here's a quote from a head of a vibration department. It said, "Today, more than 50% of the working time of my team of dynamics experts is wasted in data archaeology and IT chaos. We would select a supplier that would enable us to find and use data more efficiently across department systems and data formats." So in other words, putting the actual details of the analysis aside, just getting the right data can be a challenge. And increasingly, it's actually easier and easier to create and capture from various sources increasing volumes of data itself. So what are the needs that we see in the customer base? Well, just finding the data that's already been acquired is useful to avoid expensive retesting. We don't have to go back and retest what you already have. As we were just saying in that last quote, avoiding wasting time just looking for data. You know it's there somewhere, you just can't find it. Connected equipment, as I mentioned in the intro, is becoming more common. So connected vehicles, connected equipment that can stream data. But then you have the challenge, you've got this more and more sensor data that you're now storing, but you're not getting much value out of it. That produces issues around the general volume, variety, and velocity of all those data sources. You've just got a lot of it, lots of different types, and it's coming in all the time. And it's one thing to be able to have a very high-powered data scientist who's working on all this, who's putting together various tools, but what you really need to get value from an engineering perspective is engineers themselves need to be able to work with this data. And once you've found the data, obviously that's not the end of it. What you then need to be able to do is be able to analyze it. You need to have the right analytical tools available that can read the data, read the file formats you have, and enable you then to be able to actually derive value from all that data you've got. So a key part of this then is data search, how you then can look through large amounts of data. And as we saw before, in terms of the way that Aqira is installed and architected, you install Aqira on a company server, and you would typically have access to data within your networks, which might be terabytes of measured data. There are network drives. You may also have other accompanying documents, for example, spreadsheets, images, and you want all of that data to be centrally indexed. And by that, what I mean is that the metadata from the files is extracted and used in a way that can then be used for searches. So that could be as simple for a file. It could be as what the name is, the size, etc. But for a file format that we understand, like a measurement data, it might be a whole additional set of metadata and statistics around the file itself, max, min values, units, etc. An important part about indexing of data is that the data is left where it is on the network. So that means the data isn't copied, it isn't multiplied, isn't duplicated, it's left where it currently sits. Because most companies, when it comes to measured data, if they don't already have a measurement databasing system, will at least have a some kind of hierarchy or structure for how data is stored on some kind of system of shared drives. Indexing can be performed manually. Just put it into Aqira, but it can also be automated. We have a Python API that can automate the process. And more importantly, indexing is just the first part. That itself doesn't make it useful. What makes it then useful is the ability then to use that index and search it. And then that searching in Aqira is done within apps. And that's what we're going to take a look at. So within creating an app within Aqira, we have these certain standard components that users can then, or authors of the apps can then put together in different ways, basically the building blocks of the app that they can drag in and connect together. And we have what's called a data search component. So this is a key component for putting search into an Aqira app. And so the author can then construct the search that they want using what we call the search designer, the screenshot of the search designer there. And you can build up really complex searches based on metadata criteria, string values, but also numeric searches greater than this, less than that at either the file level, the test level, or the individual or channel level. You can build up these searches. And so you can either do that as part of a dedicated app for creating, I want to find data of a certain type, but perhaps even more usefully, you can then take that search and use that as part of an app that other people can use. So create an app for creating a certain types of data for a certain application. One thing that's new in Aqira 2020 is a new search results component dedicated for basically filtering and sorting through thousands of search results interactively. And I'll be demonstrating that in a minute. And that's probably easier just to show rather than it is to describe. So let's look at an example. In this case, we're going to be looking at proving ground data from vehicle test. A sport utility vehicle has been tested. There's multiple channels of data that's been measured, strains, accelerometer accelerations, displacements. We had a couple of different drive types, two-wheel drive, four-wheel drive variants, and also a couple of different weight conditions that have been measured. And all that data has been then arranged on a shared drive under a fixed folder structure. What we've done with Aqira then is we've gone through and recursively searched through those folders, looking for data we recognize, extracting metadata from the files and from their folder location, putting that into an index, putting it within the index within Aqira. In this case, the data files are Encode S3T files, and we've also extracted other metadata that are in those files. And so we read not only do we calculate stats on the fly, or you have the ability to calculate stats on the fly, but we also have the ability to read in existing metadata that's already embedded within those data files. So let's look at an example here where we're going to look for data files. And what we want to do is look for all four-wheel drive vehicles that are unladen. And we want to look for where the test names are related to a chatter bumps event. And we want to find all the data files where any acceleration channel was greater than 5G. So that's the kind of scenario that we've designed this app around. So let's again jump back into Aqira. We've had this open before. I'm going to close that tab and go back to the main Aqira page. So on the left-hand side, we were looking here at the flow list and remote files previously. Now we're going to go into the apps area, and I'm going to go to the app list. And here again, you've got a list just like we had in the flow list page. We now have an app list page where, so it's rather than just looking at individual flows, these are now complete apps that have been created. Again, we can search for it. We're just going to run this one that's right at the top here, vehicle data search. and I'm going to run this app. And again, it's going to open a new tab and provide a data search interface that I've actually defined around looking for this type of data. And again, this would be, you could create multiple apps for different applications. And apps have the ability to have their own custom front end. You can design the front end that you want, ask the questions that you want to simplify the usage. So here, what we've got is we've demonstrated we've presented some different options, filters that users can use for the search, the different type of vehicle that we have, what model year of data we're interested in, the drive type. Now we said in this case we wanted a four-wheel drive, I believe, unladen is what we're looking for. And this, again, this app has been created to look for channels that exceed a certain value. Now here we've got different types of measurements. I'm going to say acceleration, and I think that's the right value. I think it was 5G that we said we were going to look for. Of course, I can make this whatever I want, but let's make this 5G maximum limit. So this now, if I press this button here, it says search for tests. That's going to look for every test. In other words, it's within a file, a selection of channels. Search for tests that contain acceleration channels with more than 5G. So I'm going to press that button. It's now going to then run that search on the server and come back with the results. It tells me it's come back with 37 different tests that meet that criteria. And this is like a search results page, paginated. I can, for example, click on any of these. Open to view there. I can click on that, and that's now going to show me that test. I can open a different one, look at different tests, and this is fully interactive. This isn't a static picture. This is fully interactive display that I can work with and zoom in, etc. This is that I can then see, okay, is this the data that I'm interested in or not? So this is what I'm returning here. I'm returning complete tests with all the channels in it. Now, in this particular case, for example, I want to find where the test name contains chatter bumps. So on the left-hand side, we have a set of filters that we can then apply to reduce that list down further from the results that were found. So for example, let's say I want to say test name. As soon as I start typing, it's going to start giving me results that match that within the results that have been found. So it's going to start offering me, so if I want to pick a specific test, I can do that. In this case, what I want to do is just put a filter in, chatter bumps, so apply that filter, and now it's going to show me just the results that meet that criteria. So now I'm drilling down to the results that I'm interested in. In this case, for example, if that might be all I want to do, I can just hit selected files, and I've now got access to those raw SVT files, and I can download individuals, or I've got this option here where I can do select all, download, and it's downloaded a zip file that contains all of those data, all three events, all the channels that met that with channels that met that criteria, but it gave me the whole test and zip that up for download. So if I wanted to do more processing locally, I can. So that's finding complete files. Let's go back to the original input screen here and keep the scenario that I had here, acceleration channels of greater than 5G. But instead of clicking this search for test button that I put in this app, I'm going to hit this search for channels. So now it's going to go and find the channels that match that criteria. And it's going to come back with, it's got 133 channels. Now again, so if I click on the view here, rather than bringing back the whole test, it's just brought back results that meet the criteria. And again, you say over 5G on the individual channel. So I can do it. I can dig down into the individual channel basis for a criteria really as complicated as I wish. And that's a real nice feature. Again, it's one of the things that from an nCode automation point of view, automation has a lot of really nice features but it didn't allow that level of flexibility to really search down and pull back and visualize and interact with down to the individual channel level. So once I've got this list, obviously this is a long paginated list of results. I can, for example, sort this. So it might be useful to say sort on a different metadata item. Because I'm bringing the results back here on a per channel basis, I actually got more detail here on the individual metadata items, on the max, on the min. I've also opted to bring back other metadata items. I can choose what I bring back. In this case, a pseudo damage, a relative damage number. I could, for example, sort on max. And so this is the max value that was out of all those 133 results. I've now got those sorted across all tests or channels that matched that criteria. If I didn't want to do that, I just put that back. What might be also useful in this case is, because I've got that numeric capability, I've also got these sliders here on the left-hand side that show me all the available values that are in the search results that I've found. So I can narrow down, for example, the range that I'm interested in, and now it's down to 70 results, for example. So I can keep, rather than having to guess the values, it shows me here now what the available values are that are in the available range. So in our particular case here, I think what we need to do is also put the additional filter here on. We were talking about, let's say, chatter bumps is what we were interested in. And let's say we want to do this over 10G, apply filters. So over 10G, chatter bumps, here we get 6 results back. Okay, that's great. Again, these are the individual channels that meet that condition. And I could download those individual channels, which is quite nice. I can do output channels, and it's going to extract just those channels, not the whole test, just the channels of interest. But let's say I want to go a little bit further. What I've done here in this app is actually put some options for doing some analysis. So, for example, here let's deselect and let's just pick some channels. I can say let's say I wanted to do a PSD analysis. Let's just compare these first 3. I'll put an option here to directly, rather than just outputting those channels, if I do hit the PSD button, it's going to take just those 3 channels out of those tests. It's going to perform PSD analysis and show me live here what the frequency content was of those 3 channels. That hadn't been previously calculated. That's not stored. I calculated that using a GlyphWorks flow that's running in the background as part of this app. And again, so fully interactively. Or if I can go back to those results, for example, let me just select one here, and rather than doing a PSD, let's do a rainflow count. So again, there's a rainflow count of that channel calculated on the fly. If that's interesting to me and I need to give it to somebody else, I can just hit output rainflow. There's the S3H file. I can just download it. So that really takes it to a whole other level of what you can do. And I think the important thing to note there is that apps, what you see on the screen here, if I go back to my original inputs, what you see on the screen there and what the buttons you see on the screen there are all defined by me when I create my app. So in this way, you've really got the ability, I hope you see the ability, you've got that to go beyond just search, but also the ability for engineers to create apps to add a lot of flexibility on how that's then deployed in your organization, because you can have different search apps for different groups targeted for different applications. Great. So that's hopefully gives you some idea on some of the capabilities you've got there for searching within Aqira. Let's look at our third topic now. I think we'll actually just one word here in terms of file format support. What you saw there in terms of the search was we were working with nCode file formats, S3T file formats, which is a reasonably efficient binary file format. But reality is you're going to be using, we talked about taking data from a variety of different sources. And in the test and measurement world, which is certainly where you currently may have a whole set of measured data from lots of different sources sitting on your file, on your shared drives, what you want to be able to do is from that wide range of different formats, you want to be able to access that. And I'm happy to say that because we're using a lot of the capabilities that come with GlyphWorks here, what we're also able to do for that data search is also be able to search data a variety of different formats, over 50 different time series file formats. So that includes HBM formats like Catman, Perception, SOMAT file formats, but also Brule and Care, PTI and BKC file formats, and also other brands, for example, National Instruments, TDMS files, RPC files, Jewisoft DXD files, and also vector files, for example, MDF4, ASM MDF4 files, including CAN data and ASCII versions of vector file formats as well. So that's just an example. All of those file formats could all be indexed, all extracting metadata, and then all searchable, all within, you can mix and match all those within the same search. So hopefully that gives you some idea of kind of the breadth of where you could apply Aqira. So let's turn our attention now to the third topic for today, which is Encode ES and how that applies to faster signal processing. So the challenges that we see, again, lots of data, variety of data, need for speed, need to analyze more and more data more and more quickly, and also need then to provide analytics tools that are not, just, here's some Python, go and code something. The ability to be able to use engineering tools off the shelf that can perform the type of calculations that our engineers expect to do, especially regards durability. So those predefined analytics tools, rather than expecting engineers to code that from scratch, using, for example, just Python or some other scripting tool. And nCodeDS is focused on that to enable engineers who are really overwhelmed by the amounts of measured sensor data to gain actionable insights from high performance data analytics. This is what nCodeDS is all about, and it comes built into Aqira. And the reason for that is nCodeDS is all about providing the ability to analyze huge amounts of data, which really lends itself to some kind of scalable deployment, server processing, how to make that as fast as possible, as opposed to just running on a laptop. So let's look at a couple of examples given to illustrate the kind of speed up we're talking about. So the challenge is increasing volumes of data. Test engineers are faced with processing more and more files, more channels, higher sample rates. So the question is, how can I get results faster from all these data files that I'm faced with? You've got a collection, for example, different file formats, some of the ones we were just talking about. And what we want to do is perform some kind of analysis process, for example, typical kinds of signal processing, such as Butterworth filtering to remove drift. You want to calculate channels, so some kind of calculated channels that are based on combination of multiple channels together, maybe multiplied together, averaged, etc. Rainflow cycle counting, we were looking at that in the last example for characterizing cycles in data that are useful for understanding durability loads. And again, PSD frequency content, standard types of things. These are the kind of processes you might want to do. How do we do that faster? Well, EncodeDS provides a highly parallelized stream data analytics framework, which is a next generation from an ENCODE perspective. So let's look at an example of this. Just taking one data file, for example. Each file is 370 megabytes, S3T file, 82 channels, 1.2 million data files in each, quite a bit of data. In GlyphWorks, the process would look something like this. We've come through, filter it, etc. Go through the various steps to create the analysis results. In GlyphWorks, the analysis process just for that one file would take 54 seconds. In EncodeDS, it takes 5.2 seconds, so it's over 10 times faster for processing of that data. And it does that because it has the ability to better utilization of CPU threads, and And in this example, that's just using 4 threads. So there's potential you could go even faster with a higher number of processing threads. And also, because this is being deployed in a server environment where you could have multiple of these nCodeDS processing engines, you could also simultaneously process, if you had hundreds of these files, you could process these multiple of these files simultaneously, again, giving you further acceleration over what you could otherwise do running that data through, for example, running it on a local machine. So that's one example. Here's a second example. Analytics from CAN bus data. So again, we talked about connected vehicles. Increasingly, the use of perhaps you might call lower quality or certainly higher availability CAN data is becoming, what value we can get from that. That's becoming more and more of a need to understand, especially from product usage. So in this case, a car manufacturer is developing ADAS and autonomous vehicle technology, and fleet of vehicles is providing large volumes of usage data every day in CSV files. Now, CSV files are not necessarily the most efficient or compact way of delivering data, but it's a very, very common way in a generic sense of delivering measurement data. And in this case, it's timestamp data. So it's not the high precision, high sample rate, equally spaced data of a typical data acquisition system. It's CAN type data timestamped. So the question is, how do I extract useful information from all of that high quantity of CSV files? For example, if I want to understand the severity and duration of braking events, how would I do that? Also, how do I cope with things like poor quality data? The example there, we've got these NANs, or not a number. So instead of in the data that's coming back, you don't always have good data. Sometimes data is missing, and so we need to cope with that, or non-numeric data. And that, again, that can be a big part of what slows down the analysis in the first place, is having to massage that data into a form that can be analyzed. So again, solution with EncodeDS. EncodeDS is specifically designed to cope with unequally spaced data like timestamped CAN data. And it has built-in functions for handling things like not numbers, finding and correcting anomalies, has built-in functions for things like statistics, time at level histograms. It processes that non-equally spaced data without resampling. You don't have to put it into an equally spaced data domain before you can analyze it. And it also directly reads CSV files and in a configurable way, so you can actually teach EncodeDS how to read different file formats of CSV. For processing those kind of CSV files, the kind of file example we were looking at there, you'll find that EncodeDS, certainly in this example, was over 100 times faster than Glyphworks. Now, Glyphworks is a great tool. Glyphworks is very, very efficient at handling high quality data, the kind of file formats we were looking at before, measurement data acquisition systems. It's also very graphical and very interactive, but for raw throughput capability, if you've got large amounts of data coming in, EncodeDS really takes this to a new level of what's capable, what's possible with signal processing. And in terms of the specific example, let's say we were looking again, wanting to understand braking events, to illustrate the kinds of engineering analysis you could do with EncodeDS. One of the important things that Glyphworks can do is not just look at the overall statistics, but actually dig into the data within the channels and perform analysis based on different conditions. So like in this case, every time the brake pedal is actuated, we want to find what is the corresponding vehicle speed, such that we can then calculate a drop in vehicle speed for every braking event. And then once you've got that analysis, you can find those places. You can then build a histogram showing the number of braking events by the vehicle speed reduction. So you could see what is your distribution of braking events. And also you could perform, to use a Glyphworks terminology, joint distribution calculation, which is taking it to another dimension, which is not just the number of events of a certain speed reduction, but also what was the actual event duration for each one of those events, and then put that into some kind of 3D histogram. All those calculations, that's all things that you could do, for example, using a Glyphworks flow. You can also do that with EncodeDS. And nCodeDS then gives you the ability, having done that analysis, to either then analyze each one of those sections separately that meet the criteria, or combine it together in this way to perform an overall result. So nCodeDS has a lot of capability to configure that how you want to do that. nCodeDS is callable using Python out of Aqira. That's how you set that up. And then once you've set it up, it really demonstrates, for example like this again, significant orders of magnitude speed up for the way that it handles this kind of data. In terms of technical details, we currently have over 30 different processing nodes. We term them within EncodeDS for signal processing, finding anomalies, doing stats and counting, manipulating the data. You can also put Python directly within that node. And as you'd expect from us, we also have some fatigue capabilities built in as well. And again, wide range of file format support, the ones we were talking about before. We support those data files directly as well. Specifically, we have direct capabilities for decoding CAN data directly using DBC files as part of EncodeDS. And as I mentioned, very flexible and efficient CSV file handling. So it comes to the end of the content that we wanted to cover today. So just to recap, in summary, we looked at remote encode and how that really enables you to work from anywhere using nCode in current times, work from home, using a centralized web-based system. We also looked at data search and how you could then use apps within Aqira to help find data that you've got within your own shared drives, existing data you've already got. You can index a variety of different file formats. And we also described how EncodeDS, which comes with Aqira and is really a next generation of signal processing capability, enables you to get 10 to 100 times faster signal processing.